Hello everyone, and welcome to Chemistry is Everywhere, where we talk about chemistry in the world around us. My name is Ton van Oefel, and today we will talk about carbon dioxide, CO2. Its origin, its role as a greenhouse gas, and how we can remove it from the atmosphere.
When the Earth formed, temperatures were very high and there was no liquid water. The atmosphere was formed by volcanic eruptions and consisted of mainly carbon dioxide, water vapor and nitrogen that were trapped in the Earth's crust. Then the temperature dropped, oceans formed and absorbed carbon dioxide, and microorganisms started producing oxygen. Ice core records from Antarctica allow reliable direct CO2 measurements, which show that only after 1950, when humans started massively burning coal and petroleum, the level rapidly exceeded 300 ppm, up to the present level of 420 ppm, or 0.042%. Solar radiation is mainly of UV visible and near-infrared range from 100 to 5,000 nanometer. What the Earth re-emits is in the thermal infrared range from 4 to 50 micron. The main components of air, nitrogen, oxygen and argon do not absorb any of this radiation, but CO2 absorbs in the thermal infrared and converts this into heat. This makes CO2 a very potent greenhouse gas. Future climate goals require net zero emissions, where the amount of CO2 released in the atmosphere is balanced by its removal, through measures such as reforestation and carbon capture technologies. Now let's look at some mechanisms for CO2 absorption. Plants and trees absorb around 30% of the atmospheric CO2, in a process called photosynthesis. CO2 reacts with water to form glucose and oxygen, and the reaction is powered by sunlight. CO2 is soluble in water and forms carbonic acid, just like the sparkling water we drink. The oceans absorb around 25% of the atmospheric CO2, and in seawater it is converted into carbonate and bicarbonate ions. Some industries cannot be electrified due to their high energy demands, process requirements, or lack of viable alternatives to fossil fuels. These include cement, fertilizer, aviation, and shipping. Carbon capture technologies can be used to reduce CO2 emissions. Solvent-based capture, using amine scrubbers, is the most common and mature method. Filtration using solid adsorption is mainly used with direct air capture of CO2. Challenges with these methods are the high costs and high energy requirements. The most promising technique is metal oxide looping, where a metal catalyst is oxidized by ambient air in a redox loop. This method is still in development phase and not yet commercially available.
Thank you for watching. Hope you liked it. And if you have some suggestions, questions or comments, feel free to contact us. And hope to see you again next time. Stay safe.